Pre-statistics. Graphing square root functions, Part 3. Lesson objective. Determine the domain and range of square root functions. Lesson objective. Illustration. Consider f of x equals negative square root of x minus 1. We can see that h is a positive 1, k is 0. We're not adding or subtracting anything. This function is decreasing because the value of a is a negative 1. And from the graph, we can see it's decreasing. As x gets larger, y gets smaller. So if you recall, the domain are all the possible x values. So 2 is in the domain because it has a spot on the graph. 3 is in the domain, so is 4, so on and so on. 1 is in the domain, but anything less than 1 is not on the graph, therefore it's not in the domain. So we would write the domain as all real numbers, x greater than or equal to 1. So the value of h helps us determine what the domain of a square root function will be. The range, if you recall, are the possible y values. For this example, we don't have any positive y values. 0 is on the graph, and all negative y values will have a spot on this graph. So we say that the range is y is less than or equal to 0. All negative numbers and 0. Or we can say f of x is less than or equal to 0. Let's do an example. Example 4. Sketch the graph of f of x equals negative 2 times the square root of x plus 4 minus 1. Find the domain and range of g. A is a negative number, so this is a decreasing function. Our value of h is negative 4. The value of k is a negative 1. So using these values of a, h, and k, we can see the graph of g of x is this red graph. The point h comma k is negative 4 comma negative 1. So h is going to help us determine the domain. We can't have any negative numbers inside the square root. So we want to know what values of x will always produce positive numbers or even 0. So when x is a negative 4, we have the square root of 0, which is a real number. It's 0. But numbers less than that are not. Using our graphing calculator, with this window setting, we can see the graph here. To solve for the domain algebraically, we take whatever is inside the radical and we set it greater than or equal to 0. So we have x plus 4 is greater than or equal to 0. Subtract 4 to both sides, and we have x is greater than or equal to negative 4. So as long as x is greater than or equal to negative 4, we will take the square root of non-negative numbers, and that's our domain. For the range, since the value of a is negative 2, we have a decreasing function. Therefore, we will have a maximum value at k, which is at negative 1. So our range would be all values less than or equal to negative 1. Let's do another example. Example 5. Find the domain and range for the following square root functions. A. F of x equals 3 times the square root of x. B. H of x equals negative square root of x plus 2 minus 3. And C. G of x equals 2 times x minus 4 plus 5. A. To find the domain, we take whatever is under the radical and we set it greater than or equal to 0. So for this case, x is greater than or equal to 0. That's our domain. For the range, since the value of a is 3, that's a positive number. This is an increasing function. In this case, h and k are both 0. Since the function is increasing, there is a minimum value at k. So our domain is all numbers greater than or equal to 0. And for the range, since we have a minimum, it's all values greater than or equal to 0, the minimum value. This can be verified using the graphing calculator. The x values are all positive and 0. If we have a negative, it's undefined. If we look at our y values, the smallest y value is 0. So the y's can be 0 or greater than 0, but it can't be less than 0. B, we take x plus 2 and set it greater than or equal to 0. Minus 2 to both sides, we have x is greater than or equal to negative 2. This is our domain. Our range, since a is a negative 1, this is a decreasing function. Therefore, there is a minimum at the value of k, and value of k is negative 3. So our domain is x is greater than or equal to negative 2, and our range is h of x is less than or equal to negative 3. We can verify this using the graphing calculator. Here we can see the maximum, and it's decreasing after that. These are all the possible values in the domain, and these y values are all possible values in the range. We see when x is less than negative 2, we have an error. Negative 3 is not in the domain. The largest value for the y is negative 3. After that, the values of y decrease. C, we take x minus 4, the expression under the radical symbol, set it greater than or equal to 0, solve for x. So this is our domain. Our range, since this is an increasing function, we will have a minimum at k, and that's at 5. So our range is g of x is greater than or equal to 5. This can be verified by the graph and also the table. Thanks for watching.